Okay, pre-calculus week 4, here we go. Making this video required me to use, to have a taste of my own medicine, as they say. I had to do this quiz too several times. I just took it and don't worry, got better than 60%. Well, it says I got 60. So anyway, I figured out some things, and because I don't teach trig all the time, and so I'm rusty. I had to shake off the rust here. So let's do this one together. We're going to graph the sinusoidal function. First thing to write down, sinusoidal is the general name. So don't think just because you see sinusoidal that it's sine. It could be sine or cosine. All right, but we need to figure out what it is. It has a minimum point. So, all right, so let's think back to our sine and our cosine graphs. Sine is my favorite one. It looks like that. Cosine starts up here, then it goes down and it looks like that. I mean, well, it's not exactly right. I mean, they are the same. If you zoom out, they look the same. It's just one is a phase shift of the other, right? But in terms of making the equation, we need to know that the max is at the y-intercept on the cosine graph. And what is at the y-intercept of the sine graph? That point is called the midline. The right going right through the middle of the graph is called the midline. And you see we have that thing. So that's what that is. Right in the middle of the springy shape. So if our y-intercept is the midline, we know we have sine. If our y-intercept is a max or a min, we know we have cosine. And so we have cosine. First thing to notice. Okay, and so our general function has 4 different things for us to figure out. And so this is the vertical shift of the general function. It is also the midline. Okay, this is our amplitude, the half the total height of the springy shape, as I keep saying. The C is our horizontal shift. May or may not be there. And then the B is equal to 2 pi over the period. That is what B is, okay? So we need to figure out all of those. The graph of the sinusoidal function has a minimum at 0, -3, and its midline is at 1, 1. So I am going to go ahead and graph this out. 1, 1, and 0, -3, 1, 2, 3. And okay, so the minimum is here, the midline is there, which means it goes up. So the first thing I notice is that this is negative, it's reverse. Also, I want to see what is that height there? That's the amplitude. So what is that height? We're going from -3 to 1, that's 4. That means our amplitude is 4. So I'm just chipping away at this. Also, because the midline, the minimum is at the y-intercept, there is no horizontal shift. So that's really nice. Okay, if our minimum was over here, that would mean there's a horizontal shift and we would have one more step, but we don't. And so I'm just gonna move on with my life. All right, so the midline is the D, and we know the midline, it's 1, the y coordinate of the midline. So we're gonna put a +1 out there. Now, all we have to do is find that B coordinate. So what we need to know is what is the period of our function. Okay, so what's the period? So from the midline, which is 1, 1, to the minimum, and yeah, so from the midline to the midline is right here, and the minimum is right there, and then it goes up, and then it goes up to the maximum, and then back to the midline, and back to the minimum. So knowing this distance here, still has to go up to the minimum, back to the midline, and then back. And so this is not the best drawing here, but you can see there are 4 total pieces to this function if we are given a fourth of the total distance here, just knowing the minimum to the midline. And so what is that fourth of a distance? Let's look at the x coordinates. From the midline to the minimum is 1. So midline to min is 1. The period is 4 of those put together, which is 4. So the period is 4. And the B coordinate, the thing we're putting right here, is 2 pi over the period. So we just do 2 pi divided by the period, and 2/4 is 1/2. Pi, or pi over 2. So that means we're going to put pi over 2x. And this is the part where this is the part where I know whether or not I have to re-record the video. Let's do this. X plus 1. I got it. Isn't that good? All right. Okay. So now let's go on to the word problems. All right. We can do this. It's not going to be pretty, but we're going to do it. In the month of June, the temperature in Johannesburg, South Africa, varies over the day in a periodic way that can be modeled approximately by a trigonometric function. The lowest temperature, all right, giving me a minimum here. This is not for the Algebra 1 student, let me tell you that. The lowest temperature, around 3 degrees Celsius. And the highest temperature, 18 degrees Celsius. And the temperature is typically halfway, midline, halfway on both 10 a.m. and 10 p.m. So that means the x value of 10 a.m., 10 p.m. The highest temperatures are in the afternoon. Find the formula for the trigonometric function. Okay, so I'm definitely going to draw a picture of this situation. So we have a min at 3 and a max at 18. And I definitely think that you should pause the video and try this for yourself as much as you can before you watch me struggle through it. And then a daily low at both 10 a.m. 10 p.m. is the low. Wait. Oh, halfway between okay. Halfway between the daily high and the daily low at 10 a.m. So that's the midline. All right, so if we consider our y-intercept here, could we do that? All right, let me pause the video so you don't have to just watch me ask myself questions. All right, I have asked myself some questions, and I want to tell you something. First of all, we know where it hits the midline, and we know that the maximum is here, right? So something like this. Okay, but anyway, where it goes right from the midline to the midline, that is the, oh, that is, I was going to say that's the period, but now I'm thinking that is half the period. That's the period, isn't it? So that's the afternoon. Okay, so we know half the period is from 10 a.m. to 10 p.m., 12 hours. So our total period is 24 hours. Well, that makes sense. So that's going to help us get that b value, right? So the b value is 2 pi over 24, which is 1/12 pi. So we know the b value. What about, oh, and what am I talking about? A sine or cosine, whatever it is, bx plus c plus d. Now, what we can also do is get the a value and the d value really easy, okay? The a value is the amplitude. And so if we know the min and the, oh yeah, so the only thing about my graph is it should not go down below 3 or above 18. But anyway, the min and the max we know. And so to get the a value, what we want to do is we want to do 18 minus 3, which is 15. And then 15 divided by 2, which is 7.5. So now we know our a value is 7.5. And it's looking like I could shift the midline back to 0, 0. So I'm going to choose sine. Oh, I already got my b value of 1/12 pi, and our variable is t. And we also need to get the d value, the midline. Okay, so how do we get the midline? The midline is the midpoint of the min and the max. So we add them together to get the midpoint and divide by 2. So 18 plus 3 is 21 over 2 is 11. 11? 10.5. Okay, so 10.5. So we're going to add 10.5 to get our midline. That's where that happens. And the last thing we need to talk about is the shift, the phase shift. So we can see it has a right shift of 10. So we're going to do t minus 10. And we are just going to hope that, again, got it. So we're going to say the amplitude is 7.5 sine of 1/12 1/12 pi, and then it's going to be t minus 10. Okay, put that out in parentheses, and then plus 10.5. Okay, it's just, we got it. We did it. I did it again. Oops, I did it again. All right. Now we're going to graph this with the interactive widget. Okay. And so we know our midline is at -3. So that's nice. This point right here, point's got to be at -3. There's no horizontal shift because there's no c value. So we know that we actually have a point right there at -3. We know our amplitude is -5. So we know that we're going to need to have 5 between our midline and our minimum. It's a sine function. And so 1/7 is our b value. So we need a period. Okay. And so what is the period? Well, we know that the period is 2 pi over the period equals the b value, right? And we know the b value is 1/7. So what is 2 pi? And we don't know the period, so we'll call that x. And now I have a fraction equal to a fraction. I will cross multiply. X equals 14 pi. So my period is 14 pi. So what is the distance from the midline to the minimum? That is 1/4 of the period, right? Remember we talked about that. So 14 over 4 pi is going to be the distance from min to mid. All right, so it's 14 over 4. That would be 7 over 2. So we got to go 7 over 2 pi. How the world am I going to do 7 over 2 pi? All right, hold on. Let me pause the video and scratch my head. Wow, I just realized that I was thinking 7 over 2 was a small number and that it's 3.5. So, hey, sometimes when you are a pre-calc student, you may have some, brain fog. And that's all right. So now I'm liking this. I got 7 over 2 pi is 3.5 pi. And so I got it again. This is so amazing. You guys, I was not getting these before. Maybe I shouldn't tell you that, but I should, because you may find yourself in my position. If not in this assignment, at some assignment. Okay, so now we have the phase shift. Okay, but we know that our midline is at 4. That's our midline. We know our amplitude. We know we got the sine function. So our y-intercept is the midline, except that, okay, well, let's figure out our period. Okay, wait. When we figure out the period, the only thing about it is that we have to factor out. Okay, so the period is a little tricky sometimes when you have vertical shift, and I would hate for us to get this wrong. Okay, so it's like this. It's bx plus c. The sine of bx plus c. Oh wait, I think right. I guess we're just gonna find out. Okay, sometimes you have to be careful. If it's like this, that's not the b value. But if it's distributed, that is the b value. Okay, so we're gonna find out. If I'm wrong, then I'll just be wrong. I'm not recording this all again because I have 2 more. So we're just gonna learn from my mistake. Are you ready? Okay, so one way or the other, we will find out the mathematical information that you need to know. It just might. Okay, so we are gonna go with my formula. It's not my formula. 2 pi over the period equals the b value. The b value is 1/3, although part of me is saying factor out the 1/3. And so we're going to cross multiply. X equals 6 pi. So we're going to say the period is 6 pi. And so that's the period. Then from mid to min is 6 over 4. You got to divide that by 4, which is 3 over 2, right? 3 over 2 pi. Okay, 3 pi over 2. So that is our distance from min to mid. So now we're going to graph it. We know that our midline or our midline is at 4, right? So we go up to 4, but we know it's also shifted right by pi over 3. Something like that. And then, well, that's not pi over 3, that's pi over 2. Okay. And then we also know that our amplitude is 2. So we're going to go up 2 from the 4. Okay. And now let me just pause it for a second. Ah, I figured something out. I figured out. So I did factor on my sheet. That's all I did when I paused the video. So I said to myself, that horizontal translation is not pi over 3. I know that. All right. And here's why. Because we can factor out a GCF of 1/3 from these two terms. And we end up with x minus pi on the inside there, right? And that makes our graph shifted right by pi. So it's like this, that our horizontal shift is right by pi units. And then we know our amplitude is 2, but our period, 6 pi, and then 1.5 from mid to max. This is not reflected, so all right, there we go. Fix that. So 3 over 2 pi, or 1.5. So we got to go from pi, we got to go to 2 pi, and then halfway more. And then that will give us that period of 6 pi from peak to peak. 3 pi, 3 pi. Hey, I think it's good. You don't know how good this is. Amazing. All right, I kind of just want to quit now. I'm sure you do too. All right. The graph of a sinusoidal function intersects its midline and then has a minimum at 2.5 negative 9. All right, come on, Mr. Field, you got this. Okay, so write the formula for the function where x is entered in radians. No worries. Sinusoidal, it's midline, so we know it's sine because the y-intercept is at the midline. So I'm going to write sine. The minimum point, so now I'm thinking, oh, and the midline is -6, so we're going to put a -6 out there for the d value. Now I'm thinking about what the amplitude is. So the amplitude is the distance between the minimum and the midline. And I see that from -6 to -9 is 3, right? So then our amplitude is 3. It has a minimum point. Sine usually has a maximum point from midline. So it must be -3 because of the minimum. Okay, and now we just need to figure out the inside. But guess what? Since the midline is at the y-intercept, there's no horizontal shift. There's only the period, which gives us the p-value. We got this. So the period, what is the period? From min to mid, it's going to be 4 times that, right? And so what is the distance from min to mid? That 2.5 to 0, that's 2.5. So multiply 2.5 times 4 to get your period. And that would be 2 5s, which is 10. But we can't put 10x there. We know that the b value is 2 pi over the period, which is 2 pi over 10, which is 1/5. 1/5 pi. So it's going to be 1/5 pi x. All right. So our formula is -3 sine of 1/5 pi x and then -6. Okay, unless I made a mistake, that's what it should be. I got it. All right, we are just going to make this its own video, and then I'm going to record the other videos in another separate thing. I hope this was helpful. All right, and you go for it and post anything you want in the organizer, and we'll tackle it together.